Assalamu alaikum students and welcome back to my channel. Today I am going to discuss perturbation theory. In general, we would not use perturbation techniques to solve a quadratic equation. Perturbation theory comprises mathematical methods that are used to find an approximate solution to a problem which cannot be solved exactly. By starting from the exact solution of a related problem, in previous example A, we first solved x square is equal to 1. Perturbation theory is applicable if the problem at hand can be formulated by adding a small term to the mathematical description of the exactly solvable problem. Perturbation theory is a large collection of iterative methods for obtaining approximate solution to problem involving a small parameter epsilon. These methods are so powerful that sometimes it is advisable to introduce a small parameter temporarily into a difficult problem. Finally, to set epsilon equal to 1 to recover the original problem. The thematic approach of the perturbation theory is to decompose a tough problem into infinite number of relatively easy ones. So once we understand how to perturb a simple problem, we may start to apply the techniques to more difficult one. The notation Bigot make, amongst other things, describe the error term in an approximation to a mathematical function. The most significant terms are written explicitly, and then the least significant terms are summarized in a single Bigot term. For example, we have an equation as explicit of x equal to 1 plus x square by 2 plus Bigot of x3. So the term Bigot means that it is a higher order term, so we ignore it. And so these are the least significant terms as we summarized it in a singular Bigot of x cube. So these are the error terms. Now, as indicates that 1 plus x square by 2 is less than Bigot of x power 3, as Bigot of x power 3 is the higher order term. So these are the least significant figures. Now we solve an easy and simple question on perturbation method, as considering a quadratic equation x square minus 3 plus 2 epsilon of x plus 2 plus epsilon equal to 0. So when epsilon equal to 0, then equation 1 reduces to x square minus 3x plus 2 equals 0. And from this we can, after factorization, we get x minus 2 into x minus 1 equals 0. Now whose roots are x equal 1 and 2. Equation 1 is called the perturbed equation, whereas equation 2 is called unperturbed equation or reduced equation. As you see that here in equation 2 epsilon is absent, so that's why this is called a reduced equation or unperturbed equation. Now we will solve the following example by steps. So step 1, in determining an approximate solution is to assume the form of the expansion. Let us assume that the roots have expansion in the form like this: x equal to x naught plus x epsilon x1 plus epsilon square x2 and plus and so on. So this is equation 3. Now here the first term x naught is the 0th order term, the second term epsilon x1 is the first order term, and the third term epsilon square x2 is the second order term. Now according to step 2, plugging equation 3 and equation 1. So you have as you can see here, plugging equation 3 in equation 1. Plugging equation 3 and equation 1, it means that plugging the expansion series in equation 1, the original equation. So we get x naught plus epsilon x1 plus epsilon square x2 plus so on whole square minus 3 plus 2 epsilon and 2 x naught plus epsilon x1 plus epsilon square x2 plus and so on continuously. It means that it is continuous, plus 2 plus epsilon equals 0. Now this is the equation 4. Now according to the step 3, using binomial theorem to expand this term. Now you can see that after solving by binomial theorem, we expand this equation in this form. As you can see, x naught square plus 2. Here consider x naught as a, and consider this epsilon x1 plus epsilon square x2, and plus so on equals b. Now you can get the following equation from this in expanded form: x naught square plus 2x naught, and this term plus this term whole square. Now you can get x naught square plus 2 epsilon x naught x1 plus 2 epsilon square x naught x2 plus epsilon square x1 square plus 2 epsilon cube x1 x2, and this and so on. So after this, after simplification, we get this. Now we can similarly, you can see that this is the equation 5. Similarly, you can see that 3 plus 2 epsilon and this one. Now we multiply both these terms. So after calculation, after simplification, we can get the following equation 6. Now substitute equation 5 and 6 in equation 4. Substitute equation 5 and 6 in equation 4, and we get the following equation this. So now we can collect the coefficient of like powers of epsilon, which yields, as here you can see that equation 7 is the resulted equation. Now going towards the step 4, after equating the coefficient of each power of e to 0, as you can see, these are the like power terms of epsilon. Now after equating the coefficient of each power of epsilon to 0, so we can get x square naught minus 3x naught plus 2 equals 0, and 2x naught x1 minus 3x1 minus 2x naught plus 1 equals 0, and so on. You can get the following 3 equations: 8, 9, 10. From equation 8, as we can factorize the equation 8. After factorization, we can get x naught equals 1 and 2. Now when x naught equals 1, then we can substitute it in 9, and after solving it, we can get x1 is equals minus 1. So now as when x naught equals 1, then after substituting it in equation 9, we can get x1 equals minus 1. So when x naught equals 1 and x1 equals minus 1, then we substitute these two values in equation 10. After simplification, we get x naught equals x2 equals 3. When x naught equals 2, the second term, the second value of the x naught, then equation 9 becomes, after simplification, we get x1 equals 3. And when x naught equals 2 and x1 equals 3, the equation 10 becomes, after simplification, we get x2 equals minus 3. So going towards the step 5, when x naught equals 1 and x1 equals minus 1, x2 equals 3, then equation 3 becomes, as here you can see the equation 3 in expanded form. So after simplification, after substitution these values in equation 3, and after simplification, we get a series 1 minus epsilon plus 3 epsilon square plus, and so on. The equation 11, when x naught equals 2, x1 equals 3, and x2 equals minus 3, equation 3 becomes. So when x naught equals 2, x1 equals 3, and x2 equals minus 3, equation 3 becomes. After simplification, we get a series which is equation 12, 2 plus 3 epsilon minus 3 epsilon square plus, and so on. Hence equation 11 and 12 are the approximation for the two roots of 1. You can see here, like equation 11, equation 12, these are the two approximation for the two roots of equation 1, the original equation 1. As here you can see the original equation 1. The equation 11 and equation 12 are the two approximation roots of the equation 1. Now hence now to verify the these approximations, are correct or incorrect, we compare it with the exact solution, such that as exact solution as our general equation was x square minus 3 plus 2 epsilon of x plus 2 plus epsilon equals 0. Now we simplify it simply by quadratic equation. As you can see here, we can compare it with the quadratic equation x square plus bx plus c equals 0. So we get a equals 1, b equals minus 3 plus 2 epsilon, and c equals 2 plus epsilon. Now by substituting it in the quadratic formula, you can see here, after simplification we get the equation 13 using here for this term. To solve it, we use the binomial theorem, and we have, so by after expansion the binomial theorem for this term or for this for this term, so we get a series, and after simplification we get like this series like this 1 plus 4 epsilon minus 6 epsilon square plus so on. Now you can see, putting this value in equation 13, so we have x equals 1 by 2, 3 plus 2 epsilon plus minus 1 plus 4 epsilon minus 6 epsilon square plus and so on. After simplification, some simplification we get here this equation, and after also as here is plus minus, so this equation, this series was for the plus term, and now after now we can solve it for the minus, and we can substitute the following value like this. You can see the expansion series x equals 1 minus epsilon plus 3 epsilon square plus and so on, so which are same as equation 11 and 12. You can see, you can compare it, x equals 2 plus 3 epsilon minus 3 epsilon square with equation 11 or 12. So here you can see which are alike. Now you can see the this equation 1 minus epsilon plus 3 epsilon square and compare with the equation 11. So you can see here. So our question is verified, and so our question is solved. Okay, Allah Hafiz.